Hi, I've got a lesson here for you to watch today on solving linear systems by substitution. It's lesson 7.2 in your book. Uh, Today in class we worked on how to solve linear systems by graphing. We've been doing a lot of graphing. Probably be very glad to know that we're going to get away from graphing and see some other ways to solve these. First thing I'd point out to you is your book will write the equations much like you see this example 1 written out here, and I would advise you to write them out and don't stack them but write them side by side, so we'd have 4x plus 3y equals negative 15, and next to it have y equals x plus 2. And the reason why I suggest that is now we have room. We're going to show work under this one, and we're going to show other work under this one. And as you watch this video, feel free at any time, pause it, copy things down with me for your notes. You can also work through an example ahead of time once you get on to doing this at all, and then unpause it and see the results of me working out the answer as well. As far as substitution, you guys have done substitution before, just not quite like this. You're used to seeing it where maybe y equals something like 8. And if you saw y equals 8, you'd know you're going to bring this 8 over here and you're going to plug it into this equation for y. And then you'd end up writing down here 4x plus 3 times 8 minus 15. And then that's an equation that can be solved for x. But we don't have y equals 8. We have that y equals x plus 2. The good news is it can get solved the same way. This says that y equals that, so this is something that can just get replaced over here or substituted in for y. And if we do that, we'll have an equation that looks like this: 4x plus 3 times x plus 2 equals negative 15. Now, a lot of times the first time you've ever seen this done, you might look at that and say, can that be done? And the answer is yes, it can. You can take an equation and substitute it into another equation. The results you might look at and say, well, why would you want to do that? If you look at the top equation, you have two different variables in it. You have an x and a y, and that's an equation that you cannot solve and get an answer of just the variable coming out to a number. Once we replace the y with this, we now have an equation where the only variable that's in the equation is x. It's just in two spots. And as long as we know how to work through distributing and collecting like terms, we can go through, solve this equation for x, and we'll have that 4x plus 3x plus 6 equals negative 15. And if we combined our like terms, we will get 7x plus 6 equals negative 15. We now work to isolate the variable and we subtract 6 from both sides. That'll get rid of that. We have 7x now equals negative 21. If we divide both sides by 7, we will get that x equals negative 3. And that's half our answer. These two equations that I chose to work with here for example 1 actually are the two equations that you used in your work for today that we were doing in class, or that you might be finishing up at home tonight. And that's number 9. You had to graph y equals x plus 2, and you had to graph 4x plus 3, and where these two lines crossed was how we were finding the solutions to systems of equations. We just found out that x was negative 3, and if you notice, that is the coordinate of the x coordinate of the point where the two lines intersect. So our answer, as far as what we got for this earlier, was negative 3, and the other coordinate is here at negative 1. I've showed you how we can get this. Now I'm going to show you how to get that as far as to complete the answer without graphing it. So if we take that paper back away, this answer right here that we got of negative 3 for x, we can take that number and we can put it back into either this equation for x or this equation for x. I'm going to choose to put it into this equation for two reasons. Number one, it looks easier to solve if I put it in over there, and number two is there's nothing written here, so I can show the work of finding out what y is down here. So make sure you understand we have found out what x is. What we're doing right now is we're finding out what y is, so we're going to bring this negative 3 up here, substitute in for x, and I'll have negative 3 plus 2, and I will bring down y equals, so y equals negative 3 plus 2, which will give us negative 1. So there is my coordinate that is the solution to this system of equations. And as you can see, this answer comes out to be the same answer that we got by graphing it off of the worksheet that we completed. A couple other examples is all for you to do yet or to take a look at. Here's another one. This equation is solved for y once again. So the easiest thing to be would be to take this equation, substitute it in over here for y. And the tricky part of doing this is we're substituting in behind a subtraction sign, and there's nothing that we're going to be multiplying y by. So if I bring this over and substitute it in, 3x minus 2x plus 5 equals 10. I've actually substituted that in wrong at this point because you're supposed to be subtracting all of what y is. Now the only way to subtract all of what y is, parentheses are going to have to go around this. I might even grab a pen right now to get some color put on here and emphasize those parentheses have to get put on there. Once those parentheses are there, there's actually a negative sign that's going to get distributed to these, or if you would like to think of it as distributing a negative 1 from out in front, you can write a 1 in here too if you want. But this is going to turn into 3x minus 2x, and it's no longer going to be plus 5, it's minus 5, equals 10. And then we're ready to go on and solve this right now. So that we combined our like terms, our 3x and our 2x. This is subtracting 2x though, so this is going to turn into 1x or just x minus 5 is equal to 10. If we add 5 to both sides, we get that x equals 15. Now we actually know this number is 15. We still have to find out what the y coordinate of the point would be where these two lines would be intersecting if we graphed them. And we're going to bring this 15, we're going to bring it up here and put it in for x. So I will have 2 times 15 plus 5 will give me my answer for what y is. So y equals 2 times 15 is 30 plus 5, and I get that y equals 35. I can bring that 35 down, put it in here. There's my coordinate point that is now the solution to that system of linear equations. Alright, third example just kind of goes one step more difficult, because at this point you should notice neither equation is solved for a variable. In order to substitute in, we need to take one of these two equations and solve for a variable. If we start looking at this equation, if you solve this equation for x, we would be subtracting 6y from both sides. I don't want to write all this out, but I do want to point out to you eventually we got to divide by 4. And if we divide this by 4, we're going to have to divide everything by 4. If we divide 6 by 4, we're not going to get a whole number. We're going to either get a fraction or a decimal. And we'd prefer not to work with fractions or decimals if we can stay with whole numbers. So it's not a good idea to solve that equation for x. If you solve this equation for y, eventually you have to divide by 6, and when you do that you'll get fractions or decimals. If you divide this equation or solved it for y, and we would eventually have to divide by a negative 2, and when we divided one of the terms by negative 2 we would get a fraction of a half. So the best thing you could do as far as picking variables to solve for is to solve this equation for x. One way to look at it is it's got no coefficient, but it actually does. There's a coefficient of 1 out there in front. And eventually you'll have to divide by 1. When you divide by 1, you don't end up having any fractions or decimals develop, and really we won't even have to show dividing by 1. So to show you what we're talking about, as I start working here, I'm going to solve this equation for x. Since it's got a coefficient of 1, I'm going to add on 2y here, add on 2y here. That zeroes out, and now I have that x equals 2y minus 6. And I don't have to go through and show dividing by a number. These are just going to stay 2y and negative 6. At this point, once I've got it solved for x, I have it where this now can be brought over to the other equation and substituted in. Be careful that you substitute in for the right letter. It's that x equals this number. So we are actually going to bring this in and we're going to substitute it in for x right there. So we're going to end up with 4 times, in parentheses, 2y minus 6. Now I'm bringing down the plus 6y equals 4. And as I work through now distributing once again, I will get 8y minus 24 plus 6y equals 4. And collecting like terms, I have an 8y and a positive 6y. That's going to give me 14y minus 24 equals 4. And if I add on 24 to this side, I can get rid of it on that side. I add on 24 there, I'll get 14y equals, I should have added it there, that equals 28. Divide by 14, divide by 14, y equals 2. So now I know this is 2. I still have to find the x-coordinate that would go with it. If I bring this 2, remember I could put it back in this equation, I could put it in this equation, or I can put it in this. It'd be easiest to put it right here and just start showing my work down. X now equals 2 times the y substituted in is 2 minus 6. I'll get that x equals 4 minus 6, and I'll get that x equals negative 2. And now I see that my coordinate point is negative 2, 2. That's my answer as the solution to this system of linear equations. Thanks, and I'm hoping that's enough instruction to have you get started on your assignment when you come into class tomorrow.